as I got already presented, I think I can start right away with the speech, which is on our custom Slither detectors, which we called Slithering. If you're not familiar with the original tool Slither, or you've never heard of our library, no need to worry. I'll get a brief introduction before diving into details. Feel free to scan the QR and go back and forth the slides, click all the links, and etc. But let's start. So I think it's quite obvious from the second word in our company's name, security, what we are doing. But still, our main activity is security audits, which we are doing since 2017. And in order to help that activity, we recently started doing blockchain research and write articles on how to integrate with different large projects or how to deploy projects onto different blockchains. You can always check our blog and give us feedback. Also, in the late 2022, we started 2 development projects. One of them is Spotter, a proactive on-chain monitoring system. And actually, one of my colleagues, Evgeny, had a talk an hour and a half ago. Basically, this project is how we can prevent hacks before they even happen. So if you got interested, you can always check its website. And finally, Slithering, our custom Slither detectors, about which I'm going to tell you today. So here's a picture of young and beautiful me. My occupation is mainly research related. So for example, at Spotter, my main responsibilities are analyzing its results, suggesting features, and sometimes implementing them. Also, I'm one of the people who started Slithering in autumn in 2022, and currently I'm the one who is responsible for it. So what is Slither? Shortly, it is by far the most popular static analyzer of smart contracts codes developed by Trail of Bits. It looks for vulnerabilities and weaknesses in smart contracts and gives some recommendations on how to fix them. For your better understanding, I created a sort of a roadmap with 3 levels. Each level requires certain skills to get on, and at the same time, it gives you certain benefits. Let's start with the basic. So in my opinion, it is a must level for everyone, especially for smart contract developers, because I know that they don't really like to focus on security, and they prefer just to give their projects for an audit. But actually, running Slither is the easiest way to make sure that your code base, that foolish mistakes are not presented in your code base. So at this level, you should know how to run basic Slither functionality. Moreover, as you would get some results, and there are around 60 detectors in the original Slither, you should understand what the results mean and how you can fix them. Also, you can install Slithering, as it's extremely easy. It is done with 2 commands. You just need to clone the repository, install, and then use Slither as usual. When you've mastered the basics, you can move on to the second level. At this point, you should learn the plugins, which cover the 5% of vulnerabilities that are not covered by the original Slither. At the same time, you should not run these plugins on every code, on every project. For example, there is a plugin which checks the, which is called the ERC conformance, and which checks how you implemented the standard. So you should use this plugin on certain standards. And for example, there is an upgradability check plugin which you use on upgradable contracts. And when you've learned all the features, you're probably a great security enthusiast, or you're working on a security-related position. And at this point, you probably follow the Web3 security ecosystem, and you can expand Slither functionality by introducing your own detectors and covering what you need. That's actually what we are doing, and if you are the same security enthusiast as us, feel free to create pull requests to our library, about which I'm going to tell you right now. Currently, there are 19 detectors in our plugin, which we use on a daily basis in our audits. For example, one of them is the recent mainstream vulnerability read-only reentrancy, which is not covered by the original Slither, but which is presented in our library. Also, there is one large detector, which is called Uniswap v2, which checks the integration of your code with the Uniswap. It consists of 6 checks and provides you all the needed data, all the needed information for the secure integration. And again, it's extremely easy to install and use, just 2 commands. And I think next month we'll drop a Python package, so it would be installed with just 1 command. When I tested the presentation with my team, they told me that this slide is pretty bad. So I'll try to dive into more details so you would understand everything. It all started with a checklist. So our auditors have their checklist for the better audits. And of course, the best way to not to miss the check is to automate it. And we did some sort of a research of tools with which we can create. Well, at that point, we knew that we want to create detectors, but how we can automate the checklist. For example, we have a tool, Smart Check, which was developed by our team. But it has a lot of disadvantages, and it is pretty out of date. So Slither became the best engine for automating the checklist. The process starts with a research when I just read the checklist, see which checks could be automated. Then I perform calls with auditors, because primarily the Slither and our library is to help auditors, and I should know what they need, what checks do they want to automate themselves, how they want the results to look like, and et cetera, et cetera, et cetera. Then I add the detector into a backlog and move on to the second point, detectors assessment. This process is quite complex, but the result of it are 2 values, one of which is how much funds can potentially the detector save the protocol, and the second value is how much does it cost for us to implement the detector. When the backlog is arranged, it's time to create a detector. The structure of our code base is pretty simple. So there is a separate documentation file where we give a brief explanation what we are looking for and give some recommendations how not to make a mistake and how to make your code secure. Of course, there is detector's code, which is written in Python, and there are 2 test cases on which we are testing it primarily. A sort of a bad contract, bad function, and good contract, good function. And finally, we have a database of contracts, both off-chain and on-chain, where we test our detectors to check the false positive rate. This tool, this slide with the graph is also pretty controversial because I got some feedback that you're showing the graph where Slither is outperforming Slytherin, but I could easily comment it. We are making a tool which is not going to compete with Slither, but which is going to add functionality to it. And from the slide, which shows how many issues were found just by tools and which were included into the reports that we gave to our clients. And actually, the graph shows the spread across 12 projects that we audited recently. And I think it's quite obvious that automated tools must be used both in the development and in audits because they find a lot of bugs of all the severities. As soon as we understood that our library, our plugin gives value, well, it was a sort of a crime not to open source it. So that's what we did. Again, feel free to scan the QR or click the link to see the repo. The structure, again, is extremely simple. Documentations, README. Also, there are benchmarks which you can check, and we try to keep it up to date, and they provide information on our auditing process and how automated tools are doing them. After open sourcing the project, we were fascinated with the feedback we've got. We were included into newsletters like Week on Ethereum, Blockthread. We got a lot of positive feedback from developers, security researchers, auditors. People started joining our chat, discussing new ideas for new detectors, just automated tools, and we even received several pull requests with new detectors, and we have already merged them. Again, a sort of a crime not to continue working on the plugin, and the future plans are pretty simple. So, of course, we're going to create new detectors as new vulnerabilities occur every day, every month, every week. Also, we are going to optimize our old detectors so they produce less false positives. Moreover, we are interested in the idea of creating more integration detectors, as we've done with the Uniswap, and we actually created a demo of such detector for one of the big projects, which we'll maybe uncover anytime soon. And with 2 simple points, we are looking to form a community of people who are also enjoying the automated tools and who also think that automation is also a great way to make our ecosystem secure. Here are a couple of my links. Feel free to contact me anytime. And also there is a bunch of links of Pessimistic. Again, join our chat. And at this point, I think we can move on to questions if you got any. Yeah, thank you.
Okay, thanks for the presentation. One question from my side. On the graph that you showed, the comparison between Slither and Slytherin, do you do the delta between the two of them, or is it a benchmark that's performed directly on the code base that you tested?
No, it is just a benchmark which shows the number of issues found in our recent audits. And it is not a comparison graph, I would say. I thought that it would be just another argument to show that automated tools should be used in audits because they find bugs. Like, as you could see, like there were around 10 critical bugs that were found just by tools, and a lot of bugs of medium and low severity. And I think that currently comparing Slither and Slytherin is not the right thing to do, because they, for example, at Slither, they have around 80 detectors, and we are currently implemented 19 of them. And the number of projects that we checked is also pretty low, as we open sourced the tool, I think, 1 month ago. So I think it's just a matter of time, and of course we'll continue working on it so we could, like, next time when I'll show this graph, it would be like at least equal.
Any more questions?
Seems like no. Thank you.
Yeah. Thank you.